Okay, it's 4 o'clock. Good afternoon, everyone. My name is Matthew Zucaro. I'm filling in for our regular host, John Doring, and this is ZoomTRAK by NRail. NRail is the place for all things N-scale, whether you're into N-Track, FreeMo-N, T-TRAK, home layouts, shelf layouts, no layouts. As long as you're interested in N-scale, you're in the right place. Today we have a jam-packed lineup. We're going to have a presentation by Terry Moore on blue, white, white, blue wiring. Then we'll have a live presentation on soldering by Lee Williams. I'm looking forward to that. Can always improve my soldering skills. Then we'll slide into a presentation by Brett Isaacs on MSS. And finally, we'll do a SwitchCat's presentations by Andy. However, before we do start today's presentation, it is important that we recognize the passing of longtime NRail club president, John Wallace. And to do that, I will hand it over to Andy Zimmerman. Andy?
All right, so today, this morning, I asked if we could honor, do a tribute to John in honor of a lifelong builder of community fellowship and innovation. And with that, we'll move forward. John was born on November 28th, 1940 in Montreal, Canada. He immigrated to the U.S. Oops, I just messed something up. Hold on a quick second. I don't know what the heck I just did. Okay. All right. So he was born in, like I said, 1940, immigrated to the U.S. in 1980. He's a father of 6 children, 4 sons, 2 daughters, grandfather to 10. His wife, Sheila, passed away in 2019. He was an avid model railroader and N-scaler. John joined the NRail in 1969. He joined NRail, or then N-TRAK, in 1980. His home club, the North Raleigh Model Railroad Club, in 1980. And recently, as recent as 2022, he joined the NRV. On the national stage, John's name became synonymous with, the N-scale modular model railroad innovation. His impact was insightful as it was profound. He became the president of NRail in 2017, and he served 8 years as the president prior to his passing. NRail has only had 3 presidents: Jim Fitzgerald, Bruce Alcock, and John Wallis. As a president, John led a bold transformation. On January 1st, 2021, under his leadership, N-TRAK became NRail, an inclusive umbrella for T-TRAK, N-TRAK, FreeMo-N, home layouts, and multiple other N-scale varieties. This wasn't just a name change, it was a reimagined mission to unite N-scalers through calibration. Nice try. Through collaboration, innovation, and fellowship. In embracing technology, John used platforms like ZoomTRAK to share his passion to mentor others and to strengthen the N-scale modular community. John's work was never done. His leadership contributed, read that, was a force for developing and refining standards to ensure modules would work together smoothly and provide a consistent operation. He always encouraged others to be creative. Perhaps John's greatest gift was his role as a mentor and a connector. John's approach was always the same: inclusive, generous, and passionate. He made space for others to shine, and in doing so, he elevated the entire hobby. John Wallace leaves a legacy measured not in track or trains, but in people, friendships, and the future of the hobby that he helped shape. Through decades of leadership, writing, and volunteerism, he transformed modular railroading into a movement of community, accessibility, and innovation. His vision lives on in every NTRaK and T-TRAK module, every youth inspired to build, and every club united by shared standards and joy. John was the cornerstone of the N-scale world, and his loss is deeply felt by the North Raleigh Model Railroad Club, the NRail, the NRail, and countless N-scale modelers in organizations worldwide. John Wallace will be deeply missed for his boundless passion, selfless mentorship, and unwavering dedication to N-scale and modular model railroading. His impact lives on in the friendships he forged, the standards he shaped, and the joy he brought to the hobby. He may be gone, but he will never be forgotten. I would ask for a moment of silence to remember our friend. Rest easy, John. The tracks you laid will guide us for generations. While only a few will know the deeper meaning of this, to my friend John, fair winds, following seas, my friend, we have the watch. And back to you, Matt.
Andy, thank you for that presentation and for the solemn remembrance for John Wallace. He will certainly be missed, not only in NRail, but throughout the whole hobby. Next, we're going to move on to Terry Moore's Blue, White, White, Blue, Talking T-TRAK.
Welcome to this month's edition of Talkin' T-TRAK. This time we're going to be talking about blue, white, white, blue versus blue, white, blue, white. T-TRAK standard blue, white, white, blue wiring is still a concern for some modelers, but this very useful aspect of T-TRAK modeling is easily accommodated in both DC and DCC powered control without resorting to the blue-white wiring alternative. What is blue-white, white-blue? Blue-white, white-blue is the wiring convention that was imported from Japan with the modular model railroad format now known as our T-TRAK system. It refers to the standard cattle wiring products used to power our modules and the blue and white covering of the zip cable style wire. Also used are keyed connector plugs that prevent connection of the white wire to the blue wire in a long run of several wiring sections. By connecting the outer rails of a 2-track module to the blue wiring and the inner rails to the white wiring, 2 trains could be operated in opposite directions on a DC power supply. Since railroad operations and crossovers were not part of the original plan, this was just fine. But we have moved on. And now we must deal with this operational problem. Now, don't get me wrong. I thought blue, white, white, blue was stupid when I started T-TRAK too. But I have seen the light, and the light is good. No, it's not the oncoming train. Blue, white, white, blue allowed for the creation of the diamond junction without the need for fancy wiring or reversal sections. It's actually all red bus. No matter how modules are positioned in a layout, blue, white, white, blue allows it. That little S section, you might wonder, well, why didn't I just turn that S module around? The diagram doesn't show it, but there would be a siding coming off the yellow track into that double. So that's why it is reversed. And makes single row spines and branches possible without wiring modifications. Considering the T-TRAK blue-white, white-blue standard in terms of polarity, positive, negative, negative, positive is not uncommon in our layouts. Consider this simple single-track oval. Looking at both the front and back tracks, the front to back rail polarity is positive, negative, negative, positive. Sound familiar? Notice also that those diagonal crossover tracks can't be used either without some sort of polarity reversal. Again, sound familiar? Simply running trains around the oval has no electrical problems. With the diagonal tracks through the diamond wired to match the left end of the oval, trains passing through the diamond from the left or entering the cross from the right will create an electrical short circuit as they cross the turnouts on the right. If the two tracks that create the X through the diamond are designated as the reversible section, both tracks can be under a single control or separate controls. With the power supply reversed, trains can pass through the diamond as a figure-8 route or just through one, reversing train rotation around the loop layout. Now, for DCC, an auto reverser could be used. A manual reverser, DC or DCC, would require stopping the train to switch the track polarity as it passes through the cross. Designating one end of this loop layout as the reversible section might be a better idea. With the power supply reversed, trains can pass through the turnouts and the center diamond, creating a figure-8 route. But if you forget to return the reverse section back to normal supply, you will have an electrical short when trains try to go straight through those turnouts. If we squeeze the front and back straights of our little single-track oval layout together, it creates a situation similar to a two-track T-TRAK module in the middle. The resultant dogbone layout is similar to a T-TRAK module in the middle with balloon loops on each end. Trains can go straight by the crossover without any problems. Without a designated reversible power section of this dogbone layout, trains attempting to cross through the crossover will create an electrical short circuit. With the right end of this dogbone designated as the reversible section, reversing the power supply will allow trains to cross through the crossover, creating something like a figure-8 layout. But again, if you forget to return the reverse section back to normal supply, you will have an electrical short when trains try to go straight past the crossover. Now, if your modules are wired blue-white, a common so-called fix, to combat the wiring issues and allow the use of crossovers, you will need a big bunch of wiring reversal cables to allow these common layout configurations. or other corrections, including not connecting modules to their respective power bus. Now, those are the same little diagrams we had before. The S section, both of those modules will need wiring reversal on both tracks. The single line branch at the bottom will need, depending on how that thing is tapped into the rest of the layout, the wiring is going to be in need of help. And back over on the other side with the junctions, if you're going to wire that little single in the middle, you will need to have a reverser cable on that red track. So, creating polarity reversal cables. Required: cattle wiring products and a 1/8" piece of brass tubing. Those cattle wiring products on the left are the DC extension cord, typical blue and white, and connectors. But you might be surprised by that thing on the right. That's a turnout extension cord. It's the same thing, only different. In this case, different colored wire sheeting. Insert the tubing over the pin in the one connector, thereby squeezing the securing wings to the pin. The tubing squeezes the wings to the pin, allowing the pin to be pulled out of the housing. I tried to put an inset in there so you could see the little wings we're talking about. I'm afraid it's still not the clearest, but you can sort of see them. Place the wiring pins back in the plug body in their reverse locations. The completed reverser cable showing the reversed wiring. No, I did not answer the phone. Use of the red and black cable identifies this piece of wiring as a reverser cable. Use of the blue and white cable would require special tagging or color coding. Now, these cables have many applications, not just blue-white correction. Please follow the blue-white-blue standard. It really is best. If you insist on wiring your T-TRAK modules blue-white so you can run trains on loops like this and use crossovers, I can't stop you. But it's much easier to wire modules to the blue-white-blue standard, allowing far more layout design options and simply reversing the yellow track bus power supply as desired to allow the use of crossovers. Standard T-TRAK wiring practice places the blue wires of both the red and yellow buses under the same power supply terminal, and the white wires of both buses under the other power supply terminal. If multiple power supplies are used, connections must be identical on all power supplies. Separate power supplies may be used for each bus. The alternate wiring practice places the wires of the yellow bus under the opposite power supply terminals of the red bus, creating a reversed polarity wiring condition at the rails of the yellow track, of the track supplied by the yellow bus, allowing the use of crossovers. If multiple power supplies are used, output terminal polarities must be identical on all power supplies. Separate power supplies may be used for each bus. Many layouts do this yellow bus power reversal as a normal procedure to allow the use of crossover tracks throughout the whole layout. Now, for the sake of this presentation, I have assumed the normal blue-white-white-blue wiring has the positive polarity on the blue wire and negative on the white wire. Reversing the yellow track bus connections at the power supply does not change the blue-white-white-blue wiring, but only changes the polarity of the yellow track rails, allowing the use of crossovers. I'm afraid that no matter what we do, operating trains powered by electricity through the rails, various layout designs will require electrical polarity reversal by an auto reverser in DCC or a manual reversal of DC or DCC as we operate our trains to the full potential of our layouts. For DCC-powered layouts, there is the ZoomTRAK's AR1 auto reverser. For DC or DCC layouts, there is the double pole, double throw toggle switch reverser. Thanks for watching.
Thank you, Terry, for that presentation. I know for many modelers, and myself included, wiring can often be the least enjoyable part of the hobby. But Kata really does make it quite a breeze with their different connectors that they have. Also, too, you can purchase those connectors aftermarket on Amazon. The same does apply, too, for the Woodland Scenics Just Plug lighting system. So you don't have to get it direct from the vendor. There are options available on Amazon to make your own if you wanted to. Next, we're going to move into another wiring related presentation. This one's going to be covering soldering by Lee Williams. Lee, I will pass it over to you.
Lee, are you muted?
There you go. Okay, can you hear me now?
Yeah.
Okay. And you should be able to see it full screen.
Yep, now it is.
Okay, good. A little while back, Bruce showed me a question somebody had posted. Should track wires be soldered to the inside or the outside of the rails? And asked me to do a presentation. And I'm going to start by saying never solder track wires to the inside of the rail. The NTRaK module manual says in the standards under track feeders to use solid core 18 to 12 gauge insulated wire must be soldered to the outside or the bottom of the rails. So I'm going to cover in this briefing how to do it both ways. I prefer soldering to the bottom of the rails. The thing about that is you have to do it in conjunction with laying the track on your modules. So the first step you need to do is to determine where you want the track feeders on your module, and cut and remove the plastic under the rails where you want to have your track feeder. And I'm showing here an example of just a piece of N-TRAK or N-scale track and a turnout with an electrofrog. Next, you need to mark the location of where the track feeders are going to go on the roadbed. So you lay your track out, go ahead and bend and cut the flex track. And then I'm showing here that I'm marking the cork roadbed as to where you want those track feeders to be located, just like that. And when you take the track off, you can see how the cork roadbed is marked. Then you drill a 5/64 or 3/32 holes for the track feeder wires between the marks, as shown here. Next, you put a blob of solder in the gaps in the bottoms of the rails. So you just take your soldering iron with a fairly fine tip and heat it up and put a little blob of solder using some flux on the bottom of the rails where the feed wires are going to go. Then you take a pair of smooth jaw needle nose pliers, flatten the end of your feed wires, and put a little 90-degree bend in it that's small enough to fit between the ties, and then tin the track feeders as shown in this picture. Also, make sure that your track feeders are long enough to reach the bus wire or terminal strip that you're going to be connecting them to on the module. Then solder the track feeder wires into the solder blob, and all you have to do is use one hand to hold the soldering iron, the other hand to hold the wire. You heat it up. You put the wire against the solder blob, heat it up, and let the wire sink into the blob of solder, as shown in these diagrams. Then insert the other end of your track feeders into the holes on your roadbed and fasten the push them down and fasten the track onto the roadbed by whatever means you like to use. Track feeders on the outside. So what if you have the track already laid and now you want to add feeders? Well, you still drill a 5/64 or 3/32 hole between the ties on the outside of the rails as shown here. And then clean the rail above the hole, get any paint or dirt off the side of the rail, apply some solder, and put a blob of solder on the outside of the rail. Then prepare the feed wire the same way you did for putting it on the bottom. Insert the feed wire into the hole with the bent tab facing the rail, and then melt the solder blob and sink the tab on the feed wire into the blob. And that's how I do it. Well, that's short and sweet.
Yeah, thank you so much, Natalie. Appreciate it.
Just that one quick thing. The same thing can be done with ZoomTRAK, and if you want to see the actual ZoomTRAK example, just put that in the in our survey at the end that you'd like to see the same thing done specifically with ZoomTRAK. Go ahead.
Perfect. Thank you, Bruce. And of course, at the end of our presentation, there will be a survey sent out to everyone here on the call. We ask that you fill it out. It lets us know what your interests are. That way we can keep doing the programming. Next, we're going to move on to an intro to MSS by Brett Isaacs.
All right, we'll start that up. Right now.
Hello, everyone. My name is Brett Isaacs, GRVS member in Minnesota, and I am here to give you a basic introduction on MSS for T-TRAK. What is MSS? MSS is a signaling system. It's a standard that's been around for some time. We are using it for animating model railroad signals that is achieved by not needing to modify any of your current railroad equipment and no need to use any external fancy software. The trackside signals using MSS will change the aspects based on your train movement by monitoring a current and optical detection concurrently. MSS is a simulated ABS type system, which is an automatic block signal system. Any type of signal and any number of tracks can be monitored with this standard using network and crossover network cables, along with commercial hardware detectors and drivers that are available as well. We have chosen specifically to use ISC. I'll talk about that more in a while. The MSS system is broken down into several layers. This makes it easy for terminology to understand it, to build it, and to troubleshoot it. The MSS layers are, I have them color coded here. You will see that on the next slide correlating to these color codes. We have an occupancy bus layer. This is the backbone of the system. It carries all of the track occupancy status via network cables between the detection and the signal layers. Within that layer, you have cascade elements, which is between our block boundaries, and you have crossover elements, which is the area between those block boundaries. Next, we have a detection layer, the sensing part of the system for the presence of our turnout positions via the various detection products. That is broken down into a current element, which is a toroid style detection. We are currently using an atom from ISC. Talk about that more later. And we are also using the optical element of the infrared style detection, which is a train spotter also offered by ISE. The last layer is the signaling layer. Apologies. The logic side is what this whole system is, and it controls the signals through various commercial board options and any RGB LED signal on the market. Currently, we are using Atlas G-hood signals because they are plug and play. Also, I'll talk about that more in a little bit. Here you can see the MSS layers drawn up. You have your track power bus. On that, you have then your occupancy bus layer, which is all the orange. All the current and signaling layers fall into the detection layer, right? So that's your blue and yellow, and then you come back here and you see the signaling layer, and that is the yellow, which would be your optical. Your actual signals on the track. The brown represents the modules. The black line is just a simple track drawing. So this is your basic layout of your MSS layers. The basics of the MS operation. A quick drawing here. We do set up with a west to east or left to right flow from the front of the modules. This system detects all your electrical current in the track power feeders using the blue wire off of our BWWB system. This determines if our train is present within a specific block. The current detector activates when that locomotive draws power from the track. This is in combination with the optical sensor, which will change the aspect of your signals. Note that DC power to the boards is not shown here, just for simplistic purposes. But these are the ISE products that we're kind of overlaying on here. Your MSS detection, that is your network cabling. Our optical isolation is done with unijoiners, and then right now this would represent an Atlas signal. Very basic, very simple for this presentation. Next, we talk about the benefits of MSS. It's modular, and we are a modular organization, so this is perfect. Any block size and any layout configuration this can be added to, it automatically displays the signal aspects like your stop, your approach, your clear. In a future Zoom, we will take this more in depth, and there are some modifications we can make to add different approach systems. It is reliable for the timing for lots and lots of trains on a busy layout. So if you want to get everybody organized and not have everybody bumping into each other, use your MSS signals to have everybody follow the flow of the train and start and stop and move along as they're supposed to, and leads you right into specific operations for actual operations. It automatically displays the signal aspects, which I actually just said. There's a mistake on the slide. I apologize. These signals are based on whether the block is occupied by the train, and it's fairly easy to learn and set up, and MSS enhances the realism. The public loves it. We just recently did a display at NSE in Kansas City, and when it was working down there in our trial run, we got a lot of great feedback. There are some drawbacks. Let's talk about those. There's lots of electronics, and there's lots of wiring that's needed to fit into a very small space with the modules, but it can be done, and there are ways that we can bring some of the components outside the module and put them in the wire layer area outside of the modules. There's more cabling obviously gets thrown onto the tabletop with the addition of your CAT cables. The MSS power bus, we're using our own power bus. That all can be hidden though with your materials inside your trench. It's a little pricey, but it's definitely worth it. Currently, we're looking around $250 to $350 per module, but that would be a total of for your electronic parts from ISE, your signals from Atlas, any extra cables you need to buy. If you're not building your own module and you're going to pick one up, one of the pre-mades that Sean from Klondike is going to be building and making available, and that cost is to signal both the red and the yellow tracks. So that's kind of all in, but it'll vary depending on what you need and how you're going to build. One of the other drawbacks, troubleshooting and confirming a proper installation. It's best done with more than just one signal module, and you can use an ISE troubleshooting board, which they have available, but better yet, we say build 3. Why 3? Because then you can test each aspect of your signals, red, yellow, green, along your path, and you know it all works, and that's just awesome when it all works that way. Here's a couple build images I've drawn up in a 3D fashion just to give you some simulated ideas of what it would look like. Basic single module. There is an adapter we're using for the Atlas signals. This is 3D printed. It would be made available on the NRail website once we go live with all this information. Track power drops are actually going to be on the ends of the modules, so you're going to be using the Kato kind that just plug into the modules versus something dropping in the middle of your module, and that is because at the junction of the two pieces of track, we're using the black unijoiners for isolation to set up the short side and the long side of our block on the modules. Then there's a cutout in the middle here for your optical detector. That's where the train spotter would drop through. On the back, you see we're going to have some cutouts on modules for our track bus, and then our MSS signals, which is our Cat 5/6, and then our specific power requirements. We're going to use special inputs here. This color code is subject to change on the RP. Furthermore, here's an underside of the board in 3D version and the underside of an actual module on display at Kansas City. This is my module. I tried to make it as neat as possible, but what you will see in here is the Cat 5 cables. You will see the track bus cables coming in. These boards here are our cascade elements, our signal block devices from Iowa Scale. These are the atoms. This is the current detection. And then here's the 3D printed part that the signals would attach to on top and allow the pass-through. And then it's hard to tell with this part sticking down right here. That is the actual train spotter or the optical. All this connected up makes your signal module. We have some requirements for T-TRAK. We are working on this as propose it as an RP to the board to be attached to the T-TRAK standards. We are looking at doing this right now specifically on single modules, although you can do this on any size module you want, but we're hoping to do this out of the gate with single modules to make it easier to add them into any layout, any space without having to worry about too much. There are special build requirements. We will get those out eventually, but right now Sean from Klondike is going to producing modules and have everything pre-cut from him. We have our own 12-volt power bus that we're creating. We're going to get a color code set up for that. We do not want to tie into the T-TRAK accessory bus per se. We are using double-ended signals. You need one for each track for the red yellow lines. We are using the Atlas plug-and-play system. That would be the G hoods right now. And it looks like the new Vader hoods have the same type of plug, so that would work. But the Iowa Scale Engineering Cascade boards do have RGB wire terminals, so you can use any kind of signals that you want. The two optical sensors, one for each track line. Again, that was the ISE train spotters. The two current sensors for each track line, one for each track line. We are using the Atom, again from ISE. As I said, the Cascade elements or the block signal basic module. It comes in a kit. You'd get the block, and then you get two atoms in this kit along with the train spotter. So that's kind of the best route to go there. For the Cat cabling, the standard is for Cat 5. We are finding out we can use Cat 6 as long as your crossover cables are proper. We'll cover that more in a future video, or you can go read the standard and see what that's all about. Again, the Cato unijoiner are for the gaps for our blocks, and then there's miscellaneous other cable and connection components that you may or may not have to buy depending on what you have in your stores at home. Again, the products we're using, Klondike's going to be making some modules, ISE, there's your block signal board, there's an atom detector. If you really want to look into this a little bit more, you can go to Iowa Scaled Engineering's website here and click on this lineup where the signals are. That'll give you a full breakdown of the block signal detection products. And then in conclusion, it's a very basic and simple overview. Some of the terminology might not make sense, but again, this is just a basic overview. We'll come back to it more in a future Zoom. If you want to get more information, please go to this website listed in the video here. And this is the modular signal system.info website. This is the full standard. This has been around since probably early 2000s. It's been adapted for free mode. It's being adapted now to T-TRAK. In the next Zoom, we're going to take a steeper deep dive into actual building of a module and discuss the actual components, their connections, why we are doing things the way we are doing those. This could take place during a live Train Fest video in 2025 here coming up at end of October, early November, where myself and Justin Johnson are planning on trying to put together 3 to 4 blocks and have it all operational. So if you plan on being at that show, check us out. Just want to give a shout out to the team doing the initial testing and building of what we're doing with T-TRAK and MSS. That'd be myself. Kevin Brewer is kind of our main guy out on the west side of the states, and Mike Maloney is our main guy on the northeast side of the states. We've added some individuals from the central U.S. and a little bit of the southern side of the U.S. Bruce Alcock is getting involved, Justin Johnson, Coy Coils, and Brian Mills are getting involved. So that's where we're at right now. If you're interested in getting involved with us, reach out to me or Kevin or Mike. And if you're in our regions, we can gladly show you stuff firsthand. Or we have a Discord forum, and we're welcome to invite people there. It's a little messy. You might see a lot of nonsense, but we do keep the RP that we're working on updated there and have all of our discussions about what we're building and how we're modifying and this, that, and the other. So looking forward to sharing more of this, and hopefully the next Zoom on this will be maybe November, possibly December after TrainFest. Thank you all. Have a good day.
Thank you, Brett, for that presentation. Really looking forward to the next one and that possible live build that you'll be doing. I know I have a shelf layout that models a small short line, and even though the prototype didn't have any signals on it, it is really tempting to apply something like that to even a little shelf layout because it is definitely a crowd pleaser. Anytime you have kind of that action feel on your layout or T-TRAK modules, it really brings in the crowds. Lastly, we're going to switch over to Andy, who's going to do a presentation on SwitchCats. Really interested to learn what those are. Andy, I'll turn it over to you.
All right, got to unmute myself again. Sorry about all the miscellaneous noises and stuff that have been happening here. So, all right, let me go ahead and share.
Got it.
All right. So this is all about NCE's SwitchCat. You're going to notice here that these SwitchCats come in different revisions and whatever, and I will address those as we discuss it. But this is an NCE SwitchCat. It's a fairly simple circuit. So the Kato ZoomTRAK and LGB remote control turnouts can be DCC controlled. The SwitchCat provides connections for optional switch position indicator lights, those three little pads right there, and local control push buttons as well as DCC switching. It's a simple installation, 2 wires to the track, 2 wires to the switch, and it controls one switch. However, I have noted that it will control 2 switches at the same time, like if you have a double crossover or something like that. So if you guys, oops, sorry about that. If you guys want a quick, you want to do a screen grab, there's your part number from NCE. There's the dimensions and the UPC for it. Okay, the NCE SwitchCat is a stationary decoder designed to work specifically with Kato and LGB remote control turnouts. It does, and I'll talk about that in a little bit, it does actually work with some other turnouts as well. It contains a single switch interface and measures 2.45 inches by 1.03 inches, and it's 0.46 inches high. The SwitchCat has outputs for switch source indicator lights, and it remembers the switch position when the power was removed from the layout. So that at power on, the indicator will show the correct switch position, and this is going to be important when we get to the programming section. The address range is 1 to 2044. Easy address programming, no need to connect it to a programming track. Simple hookup, 2 wires to the track, 2 wires to the switch, as I said earlier. Connections for operation, excuse me.
Okay.
So 2 wires to the switch connections for optional local push buttons or track trips. Connections for optional position indicator lights. The SwitchCat's a single channel device, but it has enough power to throw, like I said, 2 Kato solenoids. So a single switch can do a double crossover. Both SwitchCat DCC decoders, you'll see revisions E and C here. You'll note that during this presentation that Both NCE Red C and Red E are used interchangeably. The differences are minor and they're the result of some circuit board modifications. And that came from utilizing different components on the track, excuse me, on the SwitchCat. When they had to switch manufacturers, they had to change the board. So irrespective of the revision, this decoder is designed to control, like I said before, Kato, also Lamaco, the Rapido Rail Crew, or LGB remote control turnouts. And I actually had to go look those up. So let's see here. All right, so you do not program a SwitchCat the conventional way like you would with a mobile decoder. The SwitchCats are accessory decoders, and therefore they have a whole different set of addresses. Addresses range from 1 to 2044. In order to program the decoder, you have to have it connected to both the track and the switch. You have to have, excuse me. No, that's correct. Okay, so wiring consistently is key. So we're going to go over that right now. So this is a picture of the SwitchCat and as it's connected with lights. So you'll see the programming jumper wire down here, optional indicator lights here. These are going to be lights, or they can be LEDs, and we'll get to that in a second. From up here in the upper left, it's from the DCC main track, and then lower left is out to the turnout. Okay, so you connect track power to the inputs marked track. Make sure you stay consistent with where you're taking track power, red line versus yellow line. Connect the switch power to the input marked switch. Be consistent with the wiring, especially if you're using the LED outputs. Switch wiring on the Kato switch is red and black. Wire the red to the inside and black to the outside, and I'll show you that on the next slide. So while installing the SwitchCats, I found it simplest just to remain consistent when wiring to avoid the switch being thrown to the wrong position or the LEDs from incorrectly indicating a switch position. Okay. So you're ready to program. So when you get ready to program, it's going to look like this. So the wiring should look like this. And notice to the left that I have it blue-white from the top, top left to the center left. And then from when you go out to the switch, I have it red-black. So long as, it doesn't matter where the red and black are, so long as they're the same with all the SwitchCats. Okay. All right, to avoid issues with accessory decoders, we have a block of addresses that we assign within our club and within other clubs that we run with. This provides any clubs we run with to prevent any issues with inadvertent switching due to duplicate numbers. So this one you'll notice as we went through it, it did it in switch number 4, and I changed that pretty quick. So it's important, the programming notes here, leave the power on when removing the jumper. For programming, do not turn it off to remove the jumper. And like I said earlier, if you power down, it remembers the last position it was in. It's not going to remember that you programmed it. It's going to remember the last position it was in. So when you remove that jumper, that was right here, this black jumper. When you remove that, you remove it with power on. And then when you shut down, it will remember that position. All right. So if you're using, I use an NCE power cab, so I walk through these instructions. So you're going to repeat the programming steps without the jumper. You're going to select the accessory, select the number of the SwitchCat, which in this case was 004, and then hit enter. You select 1 for normal or 2 for route, thrown, and listen for the audible click. Remember what I said with consistent, to wire consistently. If the switch wires are backwards, the switch will throw in the opposite direction. Now you're ready to install the indicators. So this is the optional position indicator lamps. These are 12-volt bulbs. This comes with the paperwork when you get the SwitchCat. Not a lot of us are using bulbs anymore. So, but you can use LEDs or you can use bulbs. The important thing to remember is if you're using LEDs, you have to use a resistor. You don't need to use any resistors with the bulbs because it's already 12 to 14 volts. So another important programming note, you must use a resistor, a 1K ohm resistor. When adding the LED, many of the signals you purchase on eBay or Amazon will already come with it installed. If not, it's a must, and it must be in the common anode configuration. I bought some online, didn't realize they were common cathode, and when I tried to use them, obviously it didn't work. So I had to go back and buy some more that were common anode. So real quick LED lesson. How can you tell the anode from the cathode? So the anode always has the longer lead. The cathode always has the flat, shorter lead. And if you want to know, when you're looking at it in a schematic, the anode always points at the cathode. So if you're looking at an LED and you can see through the LED has like we call it a flag. The flag side is always attached to, I think the cathode side. Okay, so SwitchCats will also work with bicolor LEDs. So I use some optional position indicator lights that I wired in. The LEDs can be cross-wired to reflect the routes. Simply connect green and opposite red to N. And hold on a quick second. I apologize. All right. All right. So since the LEDs and these signals are typically 20 milliamps, I can run 4 signals. No more than 4 LEDs operational at one time would be about 80 milliamps on a 100 milliamp circuit. I wire the signals in pairs and connect the LEDs so that they flip when switched. So when they're wired, and I'll show you this in a second, I wire, if I've got 2 on one end of the switch, I wire them so when one goes green, the other one goes red. Oops. All right. So LEDs can be cross-wired, as I said earlier. Routes simply connect green and the opposite red to the N output and vice versa for the R signal. Since LEDs and these signals are typically, and I already said all that, so I'm sorry. Not sure why I left that there in the notes. So for the optional position indicator lights, if you don't want to solder connections, but you still want a good solid connection, consider using these 3-pin, 3-pole plug-in screw terminal blocks. You only have to wire this backwards one time to understand why those are important. So I've done it inadvertently. I've done it inadvertently, and I've soldered them in place backwards. So having these terminal blocks in this, where you see the N and the R, having them here makes it very simple to change the wiring very quickly. You can buy those off of Amazon, by the way. So the beauty of the whole SwitchCat thing and having it being a stationary decoder is that you can program these into JMRI and have them recognize your SwitchCat and recognize your switches and throw those switches for you. So if you want to see your switches show up in like Y throttle or engine driver, because many of us use a wireless system when we're running our T-TRAK modules, then you'll need to establish them within the JMRI turnout table. So in JMRI, you'll need to get these new turnouts set and established. In Panel Pro, you're going to, and I'm going to show you this, Panel Pro, you're going to click Tables, Turnouts in Tools menu, and bring up the turnout table. Click the Add button, and at the bottom of the pane, bring up the Add Edit Turnout pane. And again, I'm going to show you this in a minute. When adding a turnout from the system connection drop-down list, select the hardware connection this turnout is attached to. And in my case, it was an NCE system. In many of your cases, it'll be Digitrax or something else. Enter a valid hardware address for the turnout. You can look at the tooltips for input options. In the following example, I'm going to use 1005. If desired, enter a username, which can be anything you wish it to be to describe the turnout. And in this case, it was on my module called the Empire Leather. So it's the Empire Leather siding. Then click the Create button at the bottom of the pane. If everything's fine, the new turnout will appear on the turnout table. If there is trouble with anything, an error warning will be displayed on the screen, and you should correct that arrow and then click Create again. Again, I'm going to show this physically. And then click the button in the state column. This should toggle the turnout back and forth. If you hear an audible click, then you know that it's been added correctly. All right. And I'm sorry. All right. So in Panel Pro, you're going to click Tables, Turnout in the tables, and bring up the turnout table. So you're going to go to Tools, Tables, and then click on Turnouts. And then you're going to click the Add button. It's down the lower left. And that's going to bring up the Add and Edit Turnout pane. So when adding a turnout from the system connection drop-down list, select the hardware connection this turnout is attached to. And why is it not? Okay. In this case, I had to select NCE. Again, you would select Digitrax or whatever your system is within JMRI. If you wish to add a number of turnouts all at once, there's an Add a Sequential Range button up here. So you can add a range check. You can click the Add a Range checkbox, and then in the number to add field, enter the number of the turnouts you wish to add. So if it's 10 turnouts, you're just going to, over here, you're going to put in 10 turnouts, and it'll start adding them sequentially. All right. So the next step was enter a valid hardware address for the turnout. And so here we added switch number 1005 or address 1005 for the switch. And again, I placed the username, just the description of that switch, that it's the switch on, it's the Empire Leather Factory siding switch. Okay. And you don't have to put that there. It's only if desired. And it can be anything you wish it to be. All right. So moving on. So now we're going to click the Create button. So you click create at the bottom of the pane. If everything is fine, the new turnout will appear in the turnout table. If there's trouble with anything or an error or warning message will be displayed on the screen. You would need to correct that and then click create again. All right, so click the button in the state column. You should toggle the turnout back and forth. And if you hear an audible click in the switch, you know that you've added it successfully. So if you look here, here it is in the table, NT. For any NCE switch, it'll be labeled NT. For any DigiTRAK switch, it'll start with an L. And if you've programmed them all, this is kind of an interesting little tidbit, but if you program them all as an NCE switch, if you take it and you run your stuff with DigiTRAKs, these won't appear. So there's I'm working on a program that will actually convert all of them to DigiTRAK switches or DigiTRAK names, so the DigiTRAKs will recognize them should I be in a DigiTRAKs layout. So you click the button in the state column, and it should, at this moment it says unknown, but when you click it, it should say thrown, or it'll say closed. So in this case, and I apologize for the graininess of the photo, but in this case it was closed, and then when I clicked it again, it was thrown. So I know that it worked. Now the beauty of it is, if it's the wrong way, you can go over there and click inverted on the right side there, and then it'll invert it. So thrown becomes closed and closed becomes thrown. All right. So if you head over to JMRI, you can see the instructions for adding the turnouts. And it's a simple of clicking the link for adding a new turnout. But this is what you'll see on JMRI under adding a new turnout. All right. Then you want to save your work in JMRI, because if you don't save it, if you don't store it, then when you've done all that work and then you shut everything down and to go in for dinner, and when you come back out, you fire it back off and nothing works because you didn't store it in the table. So you make sure you don't skip this step and you store everything so you don't lose your work. So, and you're going to save that table. You're going to use panels, store panels to create the file. And then in edit preferences startup, you're going to add that file so it starts up at the beginning. Now the names will always be there. So, so I said that you need to save that table. Use the panels and store panels to create the file. I'll demonstrate that here. You click on panels, and then once you click on panels, it's going to come up and under your JMRI user files, it's going to ask you, excuse me, you click on panels, you click on store panels, and then it's going to ask, it'll bring this up. And then when it brings it up, you name your panel, whatever you want it to be. All my turnouts are loaded up into this Andy's T-TRAK turnouts for all my modules. I've got about 50 modules now, and about a third of them have switches on it. So I have them all loaded up. I also run with several others, other clubs, and they, when they're running, I take their file and I load it up into my startup as well. So long as they're all recognized by the system, NCE or DigiTRAKs, then they'll all appear in Y-Throttle or in Engine Driver. All right. So I'm going to show you how to add that to the startup. So you're going to click on Preferences. and then you're going to click on Startup to the left, and you'll see the same basic 4 or 5 things come up over here on the right side. So you're going to click on Add, and then you're going to click on Open a File. And then you'll go back, it'll automatically open up to your JMRI user files. And when it does, then you're going to want to click on the turnouts panel that you created. So in this case, it's Andy's T-TRAK turnout. You click on it and then click Open. And now those turnouts will always be there when you start up. And this is very quickly some pictures here after I loaded it up into my startup panel. And I rebooted the Raspberry Pi that I use. It automatically popped up, and it popped up with the switch in the closed position. And then I clicked the switch and it went to the thrown position. This is after I did a few more of the switches and I was testing them in closed or thrown. I'm going to do a quick demonstration video here. It's just I don't know, about 30 seconds to a minute. There's 8 signals controlled by SwitchCats in this yard that I have called Sullenberger Yard. There's 4 switches with 2 signals each, so that's 8, excuse me. Yeah, so that's 8 signals. Okay, so I was learning how to add SwitchCats into JMRI and then get those into Engine Driver. And with a little help from the online JMRI user group, I was able to do just that. Ta-da! All right. So are there any questions? No question?
Andy, I'm going to go ahead and put up the
Okay.
put
up
now.
Okay, so real quick, just so that everybody understands, there's one caveat to this whole thing. So SwitchCats work beautifully. They will throw your switches either direction. They'll indicate exactly where your switches are. But if somebody comes by and manually throws the switch, then the lights don't flip. So that's the only issue that I found with them. So in order to preclude that, then on some of my modules, I started adding buttons. So they're just momentary buttons. So if you want to flip the switch one direction or the other, you just hit the momentary button and it'll flip the switch and all the indicator lights will work. So nobody needs to touch the switch. So too many times, I think while we're operating T-TRAK modules, it's just convenient to reach down and flip the switch. And then when you forget, somebody's coming through and they see that that switch in the wrong position, or they see that switch what looks like it's in the right position, and it's not. And then you end up either with a derailment or headed down the wrong path.
Perfect. Thank you so much, Andy. And I appreciate the shout out to Raspberry Pi, one of my favorite devices. Definitely a lot of a lot of uses on the layout for it. Bruce went ahead and posted the survey. If everyone could take a moment and fill that out, that'd be really helpful for us. Lets us make sure our programming is receptive to what you want. But with that, that's the end of our August ZoomTRAK. A lot of great conversations happening in the chat. As a reminder, this video will be posted on the NRail YouTube channel, normally about 2 weeks after the live session. But with that, I hope everyone has a great rest of your day. Have a lot of fun out there on the layouts and modules. and we will see you again in September. Thank you, everyone.
Matt, before we go, just one quick thing. I noticed somebody posted about the 3 wires on the switch. That middle wire is for the frog for as you throw the switch,
Yeah.
you're going to change polarity on the frog. So we can go into I'm not sure if Lee actually did something on that in more detail in the past, but if you still have any questions, just go ahead and send us an email. We can delve into that further. And also all the stuff on MSS that was presented can be used both on NTRaK and on home layouts. And we'll be covering that in more detail in the future. So
Perfect.
please do fill out the poll because it does help us.
Perfect. Thank you, Bruce. Yeah, I'm excited for that MSS signals. Again, I have a shelf layout. It wouldn't be prototypical, but I might go a little freelance and throw in some signals. Just adds a little bit of fun. But with that, guys, fill out the survey. Have a great rest of your day, and thank you all for joining us.